Hello, my name is Kevin Neely. I'm a member of segmentedwoodturners.org, an internet organization. I am going to demonstrate cutting compound mitered ring segments on my table saw. My setup uses wedgie sleds that I purchased from Pete Mark and woodturning.com, and then I modified. The left-hand sled is a wedgeless wedgie sled. I removed the top fence, which goes right here, because it's not needed for this demonstration setup. I'll turn this over. I use turner's tape to attach three 3/32 inch thick runners to the underside to raise the sled surface. I'll show you why later. The right-hand sled is from an older version wedgie sled. I modified this sled by cutting a 15-degree angle in the left edge. 15 degrees is a reasonably good angle for making 12-sided or more sided compound mitered rings. The other modification to the right-hand sled is the addition of what I call my segment sweeper. The sweeper is made from 1/8 inch thick plywood and sweeps the cutoff segments away from the spinning saw blade. The segment sweeper is why I added the three 3/32 inch runners to the left-hand sled to raise it. The segment sweeper is slightly below the surface of the left-hand sled. Also, I added a piece of thin veneer right here. It's difficult to see from this angle. It helps sweep cutoff segments. The veneer touches the spinning saw blade and is shaped so it rides under the overhang of the spinning carbide blade tips. Now I will show you how my compound mitered segment cutting setup works. I'm going to cut the end off this board. Well, thank you. The test compound mitered ring was designed using Woodturner Pro software. The ring has 12 segments. The upper diameter is smaller than the lower diameter, hence compound mitered ring. The fence miter angle is 1.53 degrees, and the saw blade tilt angle is 14.92 degrees. This photo shows setting the sled miter gauge to 1.53 degrees off square. This protractor reads angles in degrees and minutes, so the decimal degrees, which is 0.53, have to be converted for use with the protractor. I use a phone app for that. This photo shows setting the saw blade tilt angle to 14.92 degrees from vertical. I am using the 12-inch protractor blade that came with the protractor to get as much resolution as possible. The protractor blade must lay flat against the saw blade and not touch the carbide saw blade teeth. Using a flashlight on the backside of the protractor blade can be used to verify the protractor blade is flush with the saw blade and has no gaps along its length when you don't see any light. To set sled miter angles and saw blade tilt angles, I use a very accurate Marui Kaiki MP101 bevel protractor. I bought my MP101 used on eBay for around $150. The MP101 smallest graduation is 1 minute of arc, which is equal to 0.017 degrees. That's pretty small. This protractor is pretty easy to set and read. I must note that before use, all protractors should be measured for accuracy against a really good square and calibrated as needed. Another bevel protractor I like, and is also for sale on eBay, is named the Universal Bevel Protractor with Dial. Here's the dial on it. Its smallest graduation is 5 minutes of arc, which is equal to 0.083 degrees. It reads angles directly, and you don't need to convert to minutes. It is not as accurate as the MP101, but it's fairly easy to read and set. It costs around $100. Most of the other bevel protractors for sale on eBay are directly readable to 1 degree and then use a vernier scale to further read to 5 minutes of arc, which is equal to 0.083 degrees. So you have to convert angles to minutes. Their scales can be difficult to read without magnifying glasses, but they can cost as little as $50. This particular model has an integral magnifying glass. I'm going to sand the segments now. Sand all the fuzzies off. I don't want any little fuzzy to get between my glue joint and ruin my glue up. I like using these sanding blocks. They have a real flat surface, and sanding any surface of these segments that stays flat. Okay, all the sanding is completed. Just in case you're interested, the test ring wood is poplar. I'm going to now glue pairs to pairs. I'm making a tunnel vase or a pencil cut. I often glue veneer. Well, I actually always glue veneer in between my segments. That's another reason I glue pairs to pairs, because I will spend some time gluing veneer, maybe 1, maybe 3 different layers of veneer in between the segments. I think veneer really makes a piece look good. Okay. I'm aligning the joints, making sure everything's aligned properly. So I'm going to glue together 6 pairs for a 12-sided ring. Make sure the glue is spread properly, evenly, and 100% along the joint. I'll use rubber bands. I have a lot of rubber bands. Glue isn't too friendly to rubber bands sometimes, so the rubber bands only last a certain length of time before I have to replace them. I replace them when they break. I don't replace them for really any other reason. One more pair remaining. All of these joints are very tight. Okay, all 6 pairs are glued. They'll look good. Now I'm going to wait about a half an hour before I glue pairs to pairs. So I'll see you back in here in a half an hour. Okay, now I'm going to glue pairs to pairs. Light sand to make sure there's no glue or fuzzies in the joint. Just a very light sand. Mostly to knock off any dust or whatever. Okay, I'm just going to glue 2 pairs to 2 pairs. Now, the idea is I'm going to make 2 half rings. And when I glue those together, you'll be able to see any joint problems, any gaps at the joint or whatever. So later on, I will glue the next segment, the next segment to the half ring and see what we get. Meet you back here in a half an hour. Pairs are glued to pairs. Now I'll glue up the half rings. Okay, the two half rings are glued. Now I will let them dry, take out the rubber bands and fit them together so we can see how good a job I did setting the angles. See you back here in about half an hour. Okay, the two half rings have been made. Now I'll fit them together to see how bad a job I did. Well, not too bad. It looks to me like if I wanted to sand the butts, that's the butts on the two half rings, I could fit the ring together and it wouldn't really be much sanding. Usually when I sand, I use my 6" by 48" sanding belt, but I rarely have it on. I just rub it back and forth, or I'll use a glass plate with a piece of full piece of sandpaper glued on, and I'll rub it back and forth until I get a perfect fit. But let's just see, just for fun, how much I would have to change an angle if I wanted to reset this and make it more perfect. I'll show you how I did the calculations. So what I'm going to do is I'm going to glue these two halves together and measure the gap being right here. Okay, let me do that. This measurement method works for pretty much any kind of segmented ring. Now that gap's on the outside, so that makes it a lot easier. So to correct this, what I would do is, since the gap is on the outside, I increase the saw blade angle. So if it's set for 15 degrees, I would set it for 15.1 degrees to make this more perfect. It would take the gap out of it. So I'm going to let this dry for a little bit. And when I come back, I'm going to measure it and show you how I would calculate how to change the angle of the blade to make that gap perfect. Okay, I'm going to try to measure this gap, and it is 0.045 inches, 45 1/1000ths of an inch. So that's my gap in inches. Take a piece of paper. And when we call this gap, X is equal to 0.045 inches. I'm going to measure the diameter. What I'm trying to do is try to find the opening gap in degrees. Diameter is equal to 3, okay, now it's 2.985 inches. So the circumference is equal to pi times 2.985 inches, and that's equal to 9.378 inches. So the gap, X degrees. So X degrees divided by 360 degrees, this is a simple proportion, is equal to 0.045 inches divided by circumference, 9.378 inches. So X is equal to 1.727 degrees. So that's the angle. Now to change the table saw blade angle, the 1.727 degrees divided by 24 cuts in 12-sided ring. So that's divided by 24. That's equal to 0.072 degrees. So that's how much the table saw blade angle has to change. So if it was 15 degrees, which it wasn't, I change it to 15.072 degrees. Now, the way to change this the right way is you change it 0.072 degrees from where it's at right now, from where it was at when it cut these 12 segments. Not from the design saw blade angle of 14.92 degrees. So if you want to make a 0.072 degree saw blade angle correction, remeasure the saw blade angle and immediately change the angle by 0.072 degrees and cut another test ring. The joint gap in our test ring has a 0.042 inch gap for some unknown reason. The reason could be the saw blade angle wasn't actually set to 14.92 degrees. Could be imperfect segment cutting, imperfect sanding or bluing, or just weird wood grain causing an effect. There's no assurance that cutting a new test ring will correct the problem, but it usually does. Let's say you cut a test ring and the gap is on the inside of the ring instead of the outside. Actually, there will be two gaps. Measure and add the gaps together and do the gap degree calculation again. In this case, you should subtract saw blade angle correction instead of adding it. Subtract the correction instead of adding it. In closing, if I made a test ring as good as the test ring, I would call it good. Then I would raise the saw blade as high as possible and perhaps cut a board to save the saw blade angle for future 12-sided compound miter ring segment projects. Okay, this is Kevin Neely. Thank you for viewing my video.